Hi everyone, in this video we are going to see about the topic stick diagram from the subject VLSI design. I am here Dr. V.S. Nishok from SNS College of Technology for this presentation. So we are going to see about introduction of stick diagram and different layers and its color code, and we are going to see some examples based on stick diagram. So we are starting with introduction. Stick diagram are useful for planning the layout and routing of the integrated circuits. Stick diagrams may be used to convey layer information through the use of color code. Stick diagram does not show the exact placement, transistor size, wire length, wire width, etc. of the components. So here in the picture shown, we are having different colors for different layers of the MOS transistor that we are used for IC fabrication. So for IC fabrication, the layout diagrams are the key players. So before drawing the layout diagram, before designing the layout diagram, the initial stage is nothing but the stick diagram. So we are seeing about the stick diagram here. So the metal, for metal, the most of the EDA tools use blue color that's shown here. Similarly, polysilicon, for polysilicon, red color is used. Metal contact, black in color, and P-type material will be shown in yellow in color, and N-type material will be mostly shown in green in color. Next, importance in VLSI design. Simplification. Stick diagrams simplify the complex process of IC design by providing a high-level overview, making it easier for designers to plan, visualize, and the visualizing the layout. Next, error reduction. They help in identifying potential design issues early in the design process, reducing the likelihood of errors in the final layout. Communication. Stick diagrams serve as an effective communication tool among team members, facilitating discussions and collaboration during the design process. We are starting with the rules for drawing the stick diagram. So we are starting with rule number 1. When two or more sticks of the same type cross or touch each other, that represents the electrical contact. So blue color, we have seen that as a metal. So here one horizontal line is touching the vertical line, so this creates a contact of metal layer. So similarly, we are taking a polysilicon. Here also one horizontal and vertical lines crossing each other, so it touches each other. Defaultly it creates a electrical contact. That comes under rule number 1. Next, rule number 2. When two or more sticks of different types cross or touch each other, there is no electrical contact. So in the above two diagrams, if you see, one polysilicon is touching with metal, there is no electrical contact because these two layers are different types. So if we need to make a contact, we need to use a black color dot as shown in the below diagram. So similarly, so the brown color line touches the blue color line. So here in the above diagram, right side, we are having no electrical contact. So there is no connection between the two layers. So if we want any connection, then we need to provide the electrical contact as shown in the below diagram. So this is rule number 2. Next, rule number 3. When a polysilicon crosses diffusion, it represents a transistor. So polysilicon comes under red in color and diffusion comes under P diffusion, either P diffusion or N diffusion. For N diffusion we are going for green in color, for P diffusion we are going for yellow in color. So in the given rule and given diagram, if you see, green color touches with red color, so that forms crosses each other, crosses the diffusion. When a polysilicon crosses a diffusion, that creates the NMOS transistor. Similarly, right side, yellow color crosses the polysilicon, so that represents the PMOS transistor. So that is rule number 3. Next, rule number 4. In CMOS, a demarcation line is drawn to avoid touching of PMOS and N MOS transistors, that is P diffusion with N diffusion. All PMOS must lie above the demarcation line and all the NMOS must lie below the demarcation line as shown here. So the brown color dotted horizontal line between the PMOS and below NMOS transistor that separates the PMOS and NMOS transistors as shown here. So these are the four different rules that should be followed while designing the stick diagram. So here we are having stick encoding for NMOS process, that is representing what are the important terms that we will be using in stick diagram, that is especially for using NMOS logic, that is NMOS process. So green color already we have seen, that is representing N diffusion, red color represents the polysilicon, blue color represents the metal, and black color dot represents contact cut. And then coming below, that yellow color square box represents the implant. So that represent depletion mode NMOS transistor, depletion mode NMOS transistor. So that yellow, whatever NMOS transistor we are drawing, so at the intersection point of polysilicon and the N diffusion, we need to place a implant representing the depletion mode NMOS transistor. So similarly, for buried contact, we need to use a brown color dot as shown here in the below diagram. So this represents the stick encoding for NMOS process. Similarly, stick encoding for CMOS process. Here most of the things are similar to the NMOS, and here coming to the CMOS logic, we will be using PMOS transistor equal number with NMOS transistor. So for representing P diffusion or PMOS transistor, we need to use yellow in color. So that is given below. And then coming to the demarcation line, so that deviates the PMOS from NMOS, so that is given in brown in color. So that represents the demarcation line. And in order to represent the VDD and VSS, we are using the black color cross. So that represents the VDD contact and VSS contact. So similarly, here we can see the diagram as we discussed. So the transistors are formed by crossing the polysilicon with the diffusion layers. So for depletion mode NMOS transistor, we are seeing the implant. So that representing the depletion mode NMOS only transistor. Similarly, coming for CMOS logic, so we are seeing the similar transistors, but the NMOS transistors are below the demarcation line and PMOS transistors should be always above the demarcation line. So with this we can stop this video, and the examples for stick diagram using NMOS logic and PMOS logic and CMOS logic will be seen in the next video. So in this video we have started seeing about the introduction of stick diagram, and we have started seeing about the rules, different rules while designing the stick diagram, and we have started seeing about the what are the colors that representing the different layers of the stick diagram. So these are the topics we have covered here. From the next video we can see the examples. Thank you.